All right, hi everyone, good afternoon. I have the second hardest slot right after lunch. The hardest slot at a conference is right before lunch. The second hardest slot is right after lunch because I have to do something so exciting that you don't fall asleep after filling your tummies with delicious sandwiches. So today I'd like to talk to you about SRE versus DevOps. Are they the same thing? Are they different? Are they competing standards? What's going on here? I gave a talk yesterday. That talk was really technical. There was live coding and some terminal. This is not that talk. This is a very non-technical talk, so if you're expecting live demos of SRE, it's not going to happen. I'm sorry. My name is Seth. I work on the developer relations team at Google. That's my Twitter handle. Feel free to tweet at me, direct message me. That's also my email at google.com, so feel free to reach out if you have any questions, comments, complaints, or concerns. So with that, let's go ahead and get started. I want to level set on the definition of DevOps because there was a really funny meme up here earlier that was Dr. Evil, and it's like, so we hired a DevOps engineer. And I want to level set because some people have different definitions. So my definition of DevOps is very simple and very straightforward. It all started with developers who were focused on agility. These developers were focused on delivering features fast. They were tasked by the business in bringing new value through features and bug fixes into the platform. And then we also had another group of people called operators or sysadmins. They went by many different titles, and they were tasked with stability. So the business said to the developers, you need to deliver new features, and they said to the operators, you need to make sure that things are stable. And those two concepts are inherently opposing. By introducing new features, we are inherently introducing instability in the system. The more features that we deliver, the more bugs that we attempt to fix, the higher the probability that we introduce instability and take down the system. And there's a number of other factors that were at play here. For example, the developers were often physically closer to the business. For example, they might be located in the same physical building as the directors and the vice presidents and the CEOs. Their office might be right down the hall. The operators, on the other hand, they often had their desk at the data center or at the co-location facility, or maybe their desk was at the main office, but they were often traveling to the data center. So they were physically further away from the leadership teams that were making decisions. Developers often came from a traditional software engineering, computer science, university background with traditional formal training. And then they might have years of experience, and they tend to focus on things like algorithms and code completion and testing and that genre of computer science. Whereas on the other side, operators generally didn't have a rigorous computer science background, right? They weren't writing self-balancing red-black trees. They were doing IT training courses, Cisco certifications, Microsoft certifications, and oftentimes they had to get down and dirty and run networking cable or patch some Cat5 cable or Cat6 cable, run some fiber. They generally had a different set of skills. And this often caused a lot of tension in the organization because at the end of the day, the developers were closer to the business and they could prove that they were driving value. But operators didn't have a lot of insight into the business. They didn't have a lot of ability to push back on the business unit. And whenever downtime happened, it was their fault. Even if developers wrote bad code and pushed bad code into production, it was the operator's fault. Why didn't you fix it? Why didn't you stop it? Why didn't you repair it faster? Why do we not have an infinite number of VMs and an infinite compute capacity and infinite bandwidth? Why have you not solved that problem? And this led to the wall that existed between developers and operators, where developers would literally throw their code over the wall, git push to production, if you will. And the operators were responsible for running this code, keeping this code running, maintaining that code, and oftentimes their jobs were on the line if they messed up. And remember, the people writing the code often have a traditional computer science background, and the people responsible for maintaining the code often have more of a practical background. They might not be as familiar with those topics. So there's a skills gap, there's a knowledge gap, and there's an organizational gap here where the business isn't prioritizing stability over delivering new features in many cases. So DevOps, in the purest definition, is about breaking down the barriers that exist between these two groups. It's about breaking down the barriers that exist between the developers who are trying to move quickly with agility and deliver new features, breaking down that barrier between the operators who are concerned with stability and making sure that the system functions and scales appropriately. Now, there's a few key ways in which we can do this. There's some concrete ideas, like put them in the same room. And there's some more abstract ideas, which we'll talk about in a little bit. But one of the other things I like to mention is that in recent years, the DevOps movement has extended into other industries. And the reason for that is that it turns out when you break down this wall, this was just the biggest wall. It was the biggest mountain. It was the biggest impedance for progress. But you break down this wall that exists between developers and operators, all of a sudden you're prioritizing stability the same that you're prioritizing feature development, you have executive buy-in, and then you go to deploy and the security team is like, whoa! No one from security has even looked at this. 6 weeks, please, right? And then you get on board, like you break down that barrier with security and you're ready to deploy and you push out the deploy and marketing is like, whoa, we did not brief the analysts, we did not talk to press, like what are you doing? You did not include us in the loop. So then the next time you include marketing in the loop, and like it's a continuous iterative cycle. And this is where you'll start seeing people be like, oh, DevSecOps, or Dev Marketing Ops, right? DevStar Ops. The principles extend beyond just developers and operators. But what we're going to talk about here today, especially with relationship to SRE, involves three key pieces in an organization. The developers or software engineers, the people who write code, the operators or SREs, the people who maintain that code and are responsible for uptime and reliability, and product managers, the people who are setting the direction for the product and features and requirements. So if we look at the purest definition of DevOps, there's 5 key areas in which the general definition of DevOps applies. The first is to reduce organizational silos. This is one of the common themes that you'll see over and over and over again when people talk about DevOps. We have to break down barriers. We have to break down barriers between developers and operators. We have to break down barriers between our executives and our individual contributors. We have to break down barriers between marketing and product, right? It's all about breaking down barriers and reducing those organizational silos as much as possible. And there's a few ways that you can do this, right? One of the ways that I've seen be the most successful is very low tech, is literally put them in the same room, right? The people who are building an application and the people who are supporting that application in production, if you just put them in the same room, it turns out that they will naturally collaborate, they will naturally build relationships together, and all of a sudden you have operators saying, hey, that's not going to work in the data center because we don't have the network bandwidth to support it, and you have developers teaching software engineering principles to operators. And this is fundamentally where we started to see tools in the ecosystem evolve, right? Tools like Chef, Puppet, Ansible, Salt, Terraform, right? They evolved out of people who had operations needs that are being solved with software fundamentals. The second principle of DevOps is that we have to accept failure as normal. As I said earlier in the other graphic, operators were often responsible for uptime to the point where if an outage occurred, their job was on the line. They had a genuine fear of being fired or terminated or punished if they didn't maintain 7,000 nines of uptime. And this is obviously a large problem. It's a large problem for the culture of the company. Anytime you have someone who doesn't feel psychologically safe in their job, they're less likely to take risks, they're more likely to quit, and from a security perspective, they're more likely to sabotage you on the way out. But from an organizational standpoint, the fact that you're afraid to take risks means that you're afraid to innovate. You're afraid to try new things. And that could be delivering features to your users or improving your deployment process, automating your deployment, automating your rollback. And because there was so much fear in those various sub-teams in the organization, oftentimes like no was the only appropriate answer. We're not going to change anything. Everything works as it is, and I'm just going to continue doing what I'm doing. And that's ultimately how an organization dies, right? We have to continuously innovate. We have to continuously produce new features and improve, the operations and the development side of things. So another key piece of the DevOps movement is accepting that failure happens. Computers are built by humans. Humans are inherently unreliable. Therefore, computers are inherently unreliable. And humans are going to make mistakes. They're going to write bad algorithms. Humans are going to make mistakes. They're going to patch a crossover cable and take down your entire network. This is going to happen. And if we accept that, we can start planning for it, and we can start creating a culture where people aren't afraid to experiment. They're not afraid of pushing bad code to production because they know that if they do that, they have the support of their team to fix it, and that their job is not on the line as long as they had best intentions. Similarly, another key piece of the DevOps movement is implementing gradual change. It's kind of like a chicken and egg problem, but because there was so much resistance and the fight between stability and agility, oftentimes this caused like quarterly or yearly deployments, because that's how long it took to get everyone in a room and everyone to agree that this was the deployment artifact for 2017 or for 2015. And this was challenging. It meant that when you were deploying something, you were deploying 1 million lines of code to production. And that meant that if something went wrong, you had to roll back 1 million lines of code in production. And then you had to trouch through 1 million lines of code to try to find the bug or the bugs that caused that customer issue or that regression. And then this just pushes deployment out even further. And this is why it was so difficult for companies to automate. So by implementing gradual change, we do two things. We accept that failure is normal, because we're gonna implement a very small change because we know that it's easier to roll back a very small change. And we might be using something like canary testing or blue-green deployment so that we roll out a change to a subset of our users in a geography, or 10% of our users get traffic. And this way, if something goes wrong, we haven't impacted our entire user base, and we can quickly roll back. And then coupled with accepting failure as normal, we plan the rollback in advance. We don't just deploy and then hope it works. We plan the rollback before we deploy. That way, whenever there's monitoring, logging, alerting is going off, there's bells and whistles, people are getting paged, you click the rollback button. You run the rollback script. There's no well, let's see if it calms itself down. All of that is determined in advance. A fourth key piece of the DevOps movement is to leverage tooling and automation. And oftentimes you'll hear people be like, oh, I'm using Chef, I'm doing DevOps. Oh, I'm using Terraform, I must be doing DevOps. And that's really not the case. The key point here is that as we move to the cloud and as we adopt more and more services and manage VMs and containers, operating on all of that infrastructure by hand is not only difficult, but it's error prone. It doesn't scale, and it's likely to be the subject of errors. And by bringing software engineering principles into the operations space, configuration management tools allowed us to provision users and packages and VMs and entire ecosystems from software. And then we can bring software engineering principles like testing, integration testing, and unit testing into that world. And then the same thing is happening in the cloud space with tools like Terraform and Pulumi that are allowing us to provision cloud infrastructure as code and test that code. And then the fifth piece of the DevOps movement is to measure everything. And this is like a Medusa, if you will, or a Hydra, if you will. You need to measure your applications and services because you have to know if things are working, if they're up. But then it's also measure your own processes, right? It's measure your own successes. So we can look at a single application and we can measure our CPU usage and our memory usage and our disk utilization. But we can also look at our deployments and we can measure the number of deployments we're doing per day. We can measure the number of rollbacks we're doing per day. We can measure the happiness on our team through surveys and empirical data. Now, slight tangent, just because you measure something doesn't mean you monitor something. And just because you monitor something doesn't mean you alert on something. And just because you alert on something doesn't mean you alert on something all of the time. So I get in this discussion a lot with people where part of the SRE culture is that we measure the things that impact our users. We alert on the things that impact our users. So I may monitor or I may measure my CPU usage, but at the end of the day, if all of my VMs are pegged at 100% CPU, but our customers are still able to click the checkout button, why should I wake someone up in the middle of the night? So there's a difference between measurement, monitoring, alerting, and alerting all the time. But you have to have those measurements so that when an alert goes off, you have something to fall back on. Now, one thing you might notice here is that these are all very abstract ideas, right? When we talk about tooling and automation, you'll notice I didn't tell you a specific tool to use. When we talked about reduce organizational silos, I didn't tell you what to do. I suggested you could put people in the same room, but that's not part of the DevOps manifesto. When I said accept failure as normal, I didn't actually tell you that you should be practicing blameless postmortems. Some of you probably thought that in your head, but this is the first time I've said blameless postmortem in this talk. These are all abstract ideas. They're high-level constructs that define how an organization should behave and how the process in the communication in the organization should occur. But what we like to kind of think of is that the DevOps principles don't tell you how to do these things. They just tell you what you should do. They don't tell you how to reduce your mean time between failure, just that you should reduce your mean time between failures. And in this way, DevOps is very much like an abstract class or an interface in programming. Now, I said I'm not going to get super technical. This is the most technical thing I'm going to say this entire talk. But DevOps defines the end result, but it doesn't tell you how to get there. And for this reason, we like to say that class SRE implements DevOps. And I'll explain this more in a moment. But we're so dedicated to this tagline that I literally have it on a shirt. So class SRE implements DevOps. If DevOps is an abstract class or an interface in programming, you can think of DevOps you can think of SRE like an implementation of that class. So the SRE brand core team always likes me to clarify that SRE was not created to satisfy the DevOps interface. They evolved independently around the same time, and in fact, Google was doing SRE around 2009 whenever the term DevOps was really initially started becoming popular. They called it SRE, but it was a secret sauce. It wasn't something we talked about publicly. It wasn't something you would find a job posting for. It was largely regarded as an advantage that we had over competition in the market. We would hire software engineers, and then you would be a software engineer focused on reliability called an SRE. Very quickly, we learned that in order to have conversations publicly, now that we're a cloud provider, to talk about SRE and to talk about how many nines do you have and talk about availability, that we have to have a conversation about SRE. So let's take a look at how SRE satisfies the DevOps interface. So the first key piece is to reduce organizational silos. Well, the way that we reduce organizational silos in the SRE model is by creating a shared ownership model between developers, SREs, and the product owners. And we do this through SLOs, SLIs, and SLAs, which I'll talk about more in a bit. But this is a shared ownership model that forces early collaboration before the first line of code is written between those three groups of people, and basically forces the development teams, the SREs, and the product managers to make choices about availability versus the agility. Next, we accept failure as normal. So the SRE model obviously advocates for blameless postmortems. That's very common in the number of the DevOps practices. But the SLOs actually account for failure. So when you're defining an SLO, the inverse of an SLO is this thing called an error budget, which is how much am I allowed to mess up in a quarter, in a year, in a month. And we'll talk about that more in detail in a bit. The SRE model encourages implementing gradual change by moving quickly to reduce the cost of failure. We advocate for small change lists, we advocate for small changes and isolated changes. Don't do the database migration in the same way that you should, in the same commit or the same deploy that you're doing the code changes, right? Make sure that you have an adapter model, those types of things. The SRE model actually heavily advocates for tooling and automation, but in a slightly different way. The SRE model advocates that developers and operators use the same shared set of tooling. So your developers are also using whatever configuration management tool you're using. Your operators are using the same, available to them the same set of tools to inspect the system. Your developers are on call the same way that your SREs are on call. They have access to the same dashboards and monitoring and metrics, unless unless legal and proprietary information is involved or customer data. But the goal of the SRE discipline is to actually automate this year's job away. So how many people have ever gotten promoted by SSHing in and restarting servers? Yeah. How many people's bosses have ever been like, hey, great job restarting servers this year. Bonus for you. Yeah, you're all laughing because it doesn't happen. Because our performance as operators isn't judged by how many servers we restart or how many times we SSH into a prod machine and run tail-f. Because I've definitely never done that this week. But one of the goals of the SRE culture is to automate this year's job away. It's to leverage tooling and automation such that the things that we have to do manually become automated. And you actually start to see a lot of this in the Kubernetes world, because Kubernetes came out of Google. So, auto restarting, health detection, movement, if a VM dies, auto rescheduling on another cluster, multi-region, multi-zonal, all of that comes out of this discipline of I shouldn't have to be paged in the middle of the night because a VM died. my infrastructure should move the workload that was on that VM or the workloads that were on that VM somewhere else, and I can have a nice little email report in the morning that summarized it for me. Right? It's about automating this year's job away. And then I would argue that SRE is like overly obsessed with measurement, but that's good because, again, just because you measure something doesn't mean you monitor it, and just because you monitor it doesn't mean you alert on it. But we measure the reliability of a system, and we have very quantitative, definitive ways in which we define reliability, SLIs, SLOs, and SLAs. But on the flip side, like I said earlier, we also measure these intrinsic things. We measure toil. Internally at Google, we send out surveys every 6 to 8 months of like, how much time are you spending on toil? How do you feel in your job? Do you think you're actually being productive? Are you contributing positively to the organization? And this data actually gets aggregated together to form a quantitative report about the health of the SRE organization, the people, but we also measure the applications and services too. So let's talk about some of these ideas in a little bit more detail. So hopefully this is a little bit clearer why we say class SRE implements DevOps. So SLIs, SLOs, and SLAs. Oh my, SL star. What are these things? So an SLI is a service level indicator. This is something like a particular up-down at a point in time, like request latency or requests per second or failures per request. So this is a particular moment in time metric, often observed by a third-party system, like a monitoring system. Then we have an SLO, which is a binding target for a collection of SLIs over a period of time. So if you go back to kind of old school calculus, right, an SLI is a point on an XY axis, and then the integral of that curve is the SLO over a particular time interval. And then an SLA is a business agreement that exists between a service consumer and a service provider that says like, hey, we're going to deliver you this much availability, and if we fail to do that, we will give you credits, money, or you get to sue us, right? These are business terms, often part of a sales agreement, and less actually part of the SRE model. And I'll show you here in a second how they work together. In general, SLIs drive the SLOs, which then inform the SLAs, but they don't necessarily dictate the SLA. So I find it easier to talk about the people involved because sometimes that makes a little bit more sense. So SLIs are determined by the site reliability engineers, the software engineers, and the product owners. They determine that, hey, at any given point, this is what up means for my service. My service is healthy if this metric. Right? And that metric might be the ratio of 500s to 400s, that might be, or 500s to 200s, that might be request latency, right? That's a discussion that happens before the first line of code is written. This is what a healthy version of our cat meme application looks like. These are the metrics. And then the SRE and the product owners work together and decide for what interval do we care? Are we talking weekly? Are we talking monthly? Are we talking quarterly? Because I have to choose my SLO based off of how much risk I'm able to accept. Because if I say I want 100% availability, that means the moment that I push out a bad code change, I have to stop pushing out features. I can only focus on reliability. But at the same time, if I choose 1.9 of availability, that might not be enough for my customers, and I might not get the level of support that I want from the SRE organization because 1.9 of availability is hours of downtime. So that's where the SRE teams and the product teams have a discussion, and they say, this is how much support we want, this is how much risk we're willing to tolerate, and that ultimately produces the number of 9s that the service is able to have. And that 9 is actually a lot higher than what we would have in an SLA, because ideally you want your SLO to break before your SLA. You want to break your own internal guidelines and your own internal bars before you ever have to give money or credits back to a customer. And then the SLA is something that is generally worked between the sales team and the customer, with some guidelines that are informed by the SLOs, like the SLA can't exceed the SLO. But in general, this is like a negotiation thing. It's part of sales. It's part of legal. Generally doesn't involve the SRE and product teams unless a customer is asking for like a ridiculous number of 9s, in which case you may have to go back and collaborate and decide like, is this reasonable? Can we meet it? Yes or no? So let's talk about this difference between like the availability target and the actual target. And we call this the error budget. But before I want to talk about error budgets, I have a slight tangent supported by graphics. How many people here have a mobile phone? with a US carrier. Wow, everyone's hand went down. I have a cell phone. I actually don't know this in the European region. It's probably similar, but I didn't look it up. But in the United States, the SLA for a cellular network provider for all of the 3 major carriers in the United States is 99%, 2 nines. That means if you have a mobile phone and you're talking to a cellular tower in the United States, you are guaranteed by your cellular provider at least 2 nines of availability, at most 2 nines of availability. Might be a little bit more, it might be a little bit less here, but it's not 100%. It's likely not 3 or 4 nines. It's likely closer to 2 or 2.5. So that means if I pull out my phone and I try to access a service, that the most availability that I can experience of that service is 2 nines of availability. Because I am governed by the least available component in my system. So let's say I'm a company that has unlimited budget, because we sell ads, and I have unlimited budget, and unlimited time, and unlimited people. And I have managed to get 100% availability between my data centers and every cellular tower in Europe. I run my own fiber. I actually have to mine my own ore because I can't trust any other ore in the system. So I manufacture my own fiber. I manufacture my own plastic wrap for the fiber. I run my own fiber with my own security vetted people. And I've somehow bribed all of the cellular towers to let me run my fiber direct to them. I have 100% availability, or at least like 10 nines, something outrageously high. And I've spent trillions of euros to make this happen. Guess what? My user still gets a 99% experience because the connection between their phone and the cellular tower is still 99%, and that's the maximum availability that they can experience. So oftentimes, striving for 100% availability isn't just irresponsible, it's actually impossible because our users are governed by the least reliable components in the system. Now, there are some exceptions to this. Healthcare and aviation come to mind, right? Aviation should not have 2 nines of availability. That's probably not enough, right? If I order my, my pacemaker for an arrhythmia and the order fails, that's not acceptable. So there are certain areas and certain industries in which 100% is a valid target, but I imagine that for the vast majority of you in this room here, 100% isn't the right target. Unless you're working in healthcare or aviation, it's probably not the best number to strive for. So, like I said, our users are governed by the least reliable component of their system. So sometimes it's not even worth optimizing for that additional 9, because each additional 9 of availability comes with cost. It comes with actual monetary costs, it comes with human costs, it comes with infrastructure costs, and it may actually be impossible. So how does this relate to SRE? Well, our acceptable risk, the amount of risk that our service is willing to tolerate, how much downtime can we incur in a month and a year, that dictates our SLO. So say we're able to incur, 25 minutes of downtime, right? That gives us 2 nines for a quarter or for a half. But what happens if we exceed that? Well, if we exceed our SLO for a particular period of time, it doesn't mean that the developers get to just sit there and party and play foosball. Deployments still happen, and this is a common misconception. People think that, oh, well, I've exceeded my SLO, I've exceeded my error budget, I can't deploy anymore. No, you can still deploy, but you can only deploy features that are vetted by the SRE teams that focus on reliability and improving the reliability of the system. So it's not like developers get to just sit back and do nothing until the clock resets. No, they're still working, but the features they're working on from the Jira board or the Trello board or whatever are the ones that are tagged reliability. They're the ones that are improving the reliability of the system. So what does this actually look like in practice? This is a much prettier version of an internal dashboard, where on the top you can see our actual SLI. So this is just one very zoomed in example. It's requests that are under 300 milliseconds. The graph is a little bit confusing because when the chart drops below the line, it means that the number of requests under 300 milliseconds has dropped, which actually means there's an increase in request latency. So it's a little bit inverse here, but so you can see here, there's a big drop in our graph, which correlates to a high increase in latency. There's been a big increase in latency over 300 milliseconds. And then in the middle graph here, in the green graph, you can see that there's a binary representation. This is our actual compliance check. The sum of the requests over some period of time, Are they above or below 300 milliseconds? And you can see that this is a step function. At any given point, we are either above or below. And then based off of that compliance, we have a budget, which looks a lot like my bank account, except upside down. So the budget, as time goes on, right, we gradually accumulate more budget over our interval, let's say a quarter or a half. We gradually accumulate more budget. Whenever we spend a little bit of our budget, you can see there's like a slight dip in some of our spending. But in general, like we had a really good streak of availability here. But then you can notice that like someone pushed something really bad. There was a really bad push, caused a global outage of some sort. And then all of a sudden we saw a steep burn in our actual budget. And that's because while that downtime is occurring, we're burning through our error budget. And if we hit the bottom of this, we're out of error budget, and we cannot deploy new features anymore. We can only deploy features that focus on reliability at that point. But you'll notice that like our budget, it's like a continuously rolling budget. So over time, we'll build up more error budget, and at some point, we'll get to a point again where our product teams and our SRE teams and our software engineering teams agree, okay, we have enough error budget now that we can take risk, and we can start deploying new features that might introduce instability into the system. So one of the last things I want to talk about is toil, and I'll be relatively quick. So toil is this word that we kind of made up in the SRE world. You might have heard it in the SRE book. It describes like, toil is best described as the thing it's not. Toil is all the things you hate to do except email, expense reports, meetings, traveling, those types of things. It's work that is generally manual, repetitive, automatable, highly tactical, but devoid of long-term value. SSHing into a system and restarting a service is like the #1 shining star example of toil. It's the most, the easiest to see example that I can come up with. Now, I said that SREs like to automate their job away, but that doesn't mean that we reduce 100% of toil. Just like striving for 100% uptime is a bad idea, striving for 100% automation is also a bad idea. And there's 2 key reasons for this. First, toil, how many people have ever had a day full of meetings? You can raise your hand, okay? Keep your hand up if you've ever had a day full of meetings where at the end of the day you hate your life. Hands went up higher, weird, right? And then at the end of that full day of meetings, you're like, I just need to do like something. I need to like be productive. And you like do something to a system. You like acknowledge an alert, or you SSH into a machine and restart a service, or you run, kube cuddle replace, and like green lights happen, and like you can go home for the day, right? How many people have ever had that, right? That's toil. But you don't want to eliminate that, because toil in small doses can deliver that level of satisfaction that you want. The other reason that toil is useful is how many people have ever taken a new job and been dumped into a production system? You have no idea what's going on. Yeah. Toil is actually a great way to learn that system. SSHing into machines, exploring the systems, poking at log graphs, but in small doses. In general, toil at a large scale will cause career stagnation. It will cause unhappiness. Again, how many times has your boss said to you, great job restarting server, Seth? Never. If you're interested more about this, you can go to google.com/SRE. There's 2 free ebooks on there. The first one is the Site Reliability Engineering book. This is like the theoretical book. The other one, the Site Reliability Workbook, is like the workbook. It's the practical one. So if you're a theoretical learner, pick the first one. If you're a more hands-on learner, pick the second one. They're both free in PDF format. So I'll quickly run through this. These are the questions that I posed in the abstract. Is SRE DevOps 2.0? No, it's not trying to be. Is SRE trying to overtake DevOps? No. Lol. Can I adopt both DevOps and SRE? Yes, if you adopt SRE, you will be satisfying the DevOps interface. But there are other DevOps interfaces that you can satisfy, like ProdOps from VictorOps is one that comes to mind. You can build your own homegrown one. Just like all squares are rectangles, but not all rectangles are squares, SRE is DevOps, but not all DevOps is SRE. Is DevOps dead? No. At least I hope not. Is your talk over? Yes. I don't know if we have time for questions.
Yes, we do.
We have time for questions. Thank you. Thank you.
So we have time for questions. Who has questions for Seth? There we go.
This is going to be real embarrassing. That was close.
Thank you, Seth. That was a really nice talk. And just to give a much more perspective, since you talked about DevOps versus SRE, so in fact, there is also a separate community around IT service management. And they also think there is an overlap between DevOps and SRE. So from your perspective, how do you see IT service management, DevOps, and SRE?
Can you define what you mean by IT service management?
So how there is some overlap and commonality between, and how all these can fit together from the process perspective.
So, but when you say IT service management, are you talking like provisioning laptops for employees?
Yeah, more from the framework perspective.
Okay.
From the, like ITIL as a framework, so that has been doing the...
I don't think it's appropriate to swear like that.
Yeah, I mean, more from the process perspective, like how those processes are still active or still relevant, even the DevOps and SRE has been there.
So I think the ITIL standards are written in such a way that you can adapt them to anything. That's the advantage and disadvantage of them. I think the same is kind of true for DevOps. Like, it's a very broad thing. And what I found in previous lives is working with people with ITIL is they want someone to come in and be like, you should do this. Because the concepts are so broad. And that's actually what a lot of companies experience with DevOps. They're like, we're trying to do DevOps, but like we're a large enterprise and we just want to pay like McKinsey or PwC to like come in and tell us what to do. They want like, we want them to set up our CI/CD pipelines. We want them to like tell us what source control to use. We want them to tell us what tools to adopt. We want to buy everything and then we want to say we're doing DevOps. And the difference that I see between like the ITIL world and like the SRE DevOps world is that in ITIL you can do that, right? In ITIL you can have PwC come in and you can pay them $1 billion and you'll satisfy ITIL and you'll be successful. But DevOps and SRE are just as much cultural movements as they are technical and tool movements. So like you can totally pay a consulting firm to come in and like build out your CI/CD pipelines and improve this and do that. But at the end of the day, if you don't have that shared ownership model, if you don't have executive buy-in, if you don't have a culture in your company that allows for that sharing, collaboration, failure, you're not going to be successful, right? It doesn't matter how good your Jenkins pipeline is. If at the end of the day, your operators are still going to get fired if they mess up, and your developers are still buddy-buddy with the VPs, and the operators have no ability to push back on that, you're not going to be successful, right? And that's not something that a consulting firm or any amount of technology is going to solve. And this is where it's a people and process problem.
Thank you.
We have time for one more question. Does anybody have another question? Back there. If you can throw the mic.
He was much better than me.
Nice throw. So thanks for the talk. I was wondering, is there a big difference between toil in SRE and waste in lean?
Is there a difference between toil in SRE and waste in lean? I don't know what waste in lean is, so I don't know how to answer that. You're talking like lean agile?
Yeah.
Yeah, I mean, I've heard that before, but I don't know how to answer that because I'd have to like do research. Probably. Does anyone else know? I'll open it up to the audience.
Waste is any action that does not provide value to the customer.
So waste is any action that does not provide value to the customer. I would say they're different then, right? Because toil does provide value to the system. It's just devoid of long-term value. So there's probably overlap, but I don't think they're the same thing, right? Because an SRE may do something that doesn't provide direct value to the customer, right? They may improve the reliability of the system. Maybe they improve the throughput of the system so that there's just more bandwidth can flow, more bits can flow. That's in service of a new feature that the developers are working on that requires that additional workload. Maybe it's like an ML-based workload that needs a lot of CPU availability, right? The customer doesn't experience the higher CPU availability. They experience the feature that was delivered by the developers. So any toil experience there, like there's things that SREs work on that aren't directly impactful to customers directly. So it's hard to measure the same way, and I think that's probably why there's a different word for it.
Great. Thank you so much, Seth. Let's give a round of applause for Seth.